Good evening YouTube, Ian here from Coolice Charge Cases and Power Supplies. I hope you're all safe and well in these still difficult times that are taking place around the world at the moment with the COVID-19 pandemic. I would imagine, much like myself and my family, with the recent talk of a vaccine now becoming available and obviously being circulated, you can obviously start to see light at the end of the tunnel. And I hope you and your family have obviously stayed safe and well in this time to obviously benefit from this as it comes along. And if you've lost someone, you have my sympathies. It's a very tough time. But anyway, I digress. As you've come to expect from me, whenever I have a new charge case to show you all, I create a video, and that's basically what I'm doing here. I'm trying obviously a similar path that I did before, whereby I use the front facing camera of my phone, and you'll have to obviously excuse me if it's shaking a little bit, because obviously I'm holding it up directly in front of me by hand, steadied against my wall. So the idea is then I can chat away to you, and then when I've done, I'll pause this video and then obviously take another video in the other direction with the back camera and go on from there. But anyway, I'm waffling on a bit too much, but it's quite funny. I'm trying to make sure my head is in shot and it's not, and obviously watch the camera at the same time. But anyway, for the eagle-eyed among you, you can probably gather what I'm going to try and show you, and it's here. I can just point to it over my left shoulder here. This is the biggest, the baddest, the most powerful, and the most amount of LiPos one of my charge cases has ever managed to charge at any one time, period. In fact, I can't really call it a case. It's a flight case. It's a server rack within a flight case. This is a custom built flight case, admittedly, built to my, I wouldn't like to say my design, but my U height that I designed the internals for. It has then been designed to be shock proof, so it's basically rack, it's server rack inside there, so it's obviously based on 1U channels, and I think this one off the top of my head is 32, so it's got 32 U channel size. That's 32 times 44.45 millimeters, and I can't remember what that is off the top of my head, but it's tall. Long and short of it is, the brief was very simple. This customer needs to charge as many LiPos as we can in the shortest amount of time possible, no matter what. No, cost wasn't really an issue as such. Obviously we don't really want to throw money away, but at the same time they have a job to do. They are essentially going to be operating a bank of swarm drones to obviously create the flashy light patterns within the sky. So they are currently in testing and working their way up from 90 odd drones, I think they did on the first test, to ultimately having 300 of these drones up in the air at any one time. Now that's, I've got the link, actually I might put it in the description. They are amazing little drones. I mean, I'm not a drone flyer by any sense of the meaning, but I can appreciate the technology involved in these drones, because they are all autonomous. The routine that they will fly is pre-programmed via a PC and then obviously uploaded to these drones or streamed to these drones. That part of it I don't know. And they will create these patterns in the sky and change colours, change positions, and all be aware of each other and where each other is, so they don't obviously hit one another at the same time. Now, that's great, but being electric, you need LiPos. In this case, I think they are 4S 4200 milliamp hours off the top of my head. So with a potential of 300 drones and the need to maybe fly at least 2 routines a night, that's upwards of 600 LiPos that need to be charged in the shortest amount of time safely as well. That's another consideration, of course. When you've got that amount of LiPos to deal with, you don't need any margin for error, if you like, when it comes to plugging them in, and that's what this setup comes. And you can just about see maybe how I've organise this. So let me break it down a little bit, and then I'll start to do the same then obviously when I turn it around. But to start with, we've obviously spec'd Revo Electrics PL8 Duo Touch chargers. Now they're empty. We are still waiting for them, unfortunately. We were promised them sooner than this. They haven't turned up. So I did get hold of the three-dimensional drawing, which allowed me to double check my dimensions and make sure everything was correct. I have got an empty shell of a PL8. Unfortunately, it was only the lower half of the case. I really wanted the upper panel as well with the bump controller on it, but that matched that. At least the bottom half allowed me to make sure that the dimensions I gleaned from the 3D drawing worked. So it did. So basically, the modules are now empty. They're ready to go. They've got all the wires there and everything else. But anyway, I'll just do it with my finger a little bit. You can see I have broken this build down into 3 individual sections, if you like, whereby, oh, let me cancel that. The guy I'm working with on these is trying to ring me in the background. I've broken this build down into 3 sections, if you like. So we have got 3 Revo Electrics PL8 Duo Touch chargers, one here, one just below, and another one lower down, which will make more sense in a little while. And then what we've done, or what I've done should I say, then I've broken down each channel of the PL8 Duo to charge 8 LiPos directly underneath it. And you can see it here. I call them pigeonholes. It'll make more sense again when I go up a bit close to it. But we've got a bank of 8 on this side, and then a bank of 8 on this side as well. And the way they're orientated directly below the channels of the charge. So 8 on this side will be channel 1, 8 on this side will be channel 2. Now in order to try and reduce the current draw of this, I did then spec a 48 volt power supply, and while I could have gone to one of my server units, we didn't in this case. We went for the tried and proven Meanwell power supply, in this case the RSP-1600 48 volt unit. Very nice, very compact, very powerful, admittedly, very heavy at the same time as well, and likewise quite expensive with it. But they work well in this. The customer wants ultimate reliability, and while the server units I make do work well, they are second hand. So you obviously have to account for the fact that you may have a failure at some point. Even one of these Meanwells could fail. That's like saying how long is a piece of string, but at least being brand new and with a 5-year warranty, you're pretty much guaranteed decent reliability out the box, and that's one of the reasons why we went for it. So each charger then obviously has the charger, its own 48 volt Meanwell power supply, and I've built that then into its own self-contained charger module, as I've called it. So the rectangular square you can see up there is one complete charging module, and the only wire going to it is a C20 AC power lead connecting the AC inlet, which is an industrial socket on the back side of this unit, which is a 32 amp capable unit. That then obviously provides the AC input into the rack. It then goes into a consumer unit. So I've brought essentially like a fuse box, if you like, and obviously fitted breakers within it. So there are 4 breakers in total. There are 3 16 amp breakers within it, one for each of the Meanwell PSU power supply leads, and then a single 6 amp breaker unit as well. And the single 6 amp is split for 2, is providing power for 2 points actually. One at the back of this on the top board. It didn't specifically need it, but I have added 2 AC cooling fans in there, and they are just basically sucking any warmed air that I would obviously expect to rise within this flight case at the back, to obviously rise to the top and then obviously be extracted out the back of the unit when it's in operation. So the single 6 amp breaker is obviously powering that, and also then underneath this charge mod, you can just about see the silver dot here where my finger is. There's a 1U pull-out drawer, and the idea behind that is it's got a USB charger within it, and a Samsung Galaxy tablet is going in there then for wireless communication and wireless control monitoring of the bump controllers. And that was another reason for going Revo Electrics in this instance. There's going to be a bump tag on each of the batteries. Ultimately, when they're being parallel charged, it'll monitor, you know, if they're bumping them, they'll monitor that they've obviously had a charge cycle, but it'll be a little bit difficult to, it won't monitor the individual internal resistance values of each battery. However, from a maintenance perspective, then when they come to charge the batteries and potentially test them on an individual basis, they can then obviously then bump the tag and revert to any information then that the bump tag stores, and obviously then feeds them back, which was another reason for going with this line of chargers again. So the whole top part there, if you like, with the charger is self-contained. The way I've created it is that it's almost like a pull-out drawer assembly, if you like. I've created two side plates, if you like, that extend backwards behind the panel, and also they're securely mounted to the back of that 12mm panel. Actually, the black panel here again is a polypropylene HDPE material, but instead of being 10mm like I would normally use, it's a 12. And there was a reason for that. Not only did I go for the thickest material for the strength, I also went for this material. It's got a mottled finish to it. Actually, it's textured. I can't remember what they call it now off the top of my head. There's some call it, the proper name for it is Pim Seal, I think, from memory, but it's basically got a textured look to it. So it not only looks professional, but it took the need away from me to actually physically cover it in carbon look vinyl film and then obviously trim out the apertures and stuff. In this sort of instance, it didn't need that. It needed something that was hard wearing, looked good and looked nice, if you like, and obviously then was nice and strong and rigid, and that's what I've got in this material, so that's good. The other reason with the thickness of the material as well, because I've bolted the quite heavy power supply to the back of this, and it all, again, the pictures that I take and show you that I'll show you at the end of this film or YouTube video will show you a little bit better. I wanted to use, instead of M5 brass inserts, I wanted to go up to M6, purely and simply because I knew there would be a bit better bite in the plastic with a much coarser thread than there would with a 5mm. So that was another reason for going for the thicker material, because the brass inserts that I purchased at M6 are also slightly deeper than 8.8mm of the 5mm version. So I needed to obviously machine any blind holes a little bit deeper than that. So basically what we've got there is, with these pigeonholes then, so we've got 8 per channel of the charger. The idea being then I have created a kind of like a holder and a backstop behind each one of those holes. So the idea is then the customer and the battery maintenance operator guys or drone operator guys will simply just slot each LiPo into one of these holes, and then there is my good friend and bloody brilliant electronics expert Steve Smith, the guy behind the ice meter again. He has designed and had made for me a custom parallel charge board PCB in 1U size with the cutouts in it, resettable polyfuses on each of the balance port connections, and basically this board only does 4S, so it's obviously got a 5-pin JST-XH for the balance connector, one above each of the holes, for example. Each one of those balance pins from the JST-XH has this resettable polyfuse. Brilliant. Safeguards any issues there, just in case someone tries to, or plugs in a balance plug that's been damaged in flight or been pinched somewhere or whatever. It's obviously safe there. For the main connector then, we've gone for XT60s. A nice simple connector, you can get it anywhere. It works well. It's capable of obviously carrying a decent amount of current, 60 amps, and potentially a bit more with the better named ones, which is more than enough for the drones that it's in. So again, on the same PCB then, it's got obviously JST. So alongside the JST connectors, it has then got the XT60s, and each one of its connections to the main copper tracks running along this custom built charged PCB also has then an inline blade fuse holder with a 30 amp fuse behind it, so the positive and negative pins off of each XT60 connector are protected by a 30 amp blade fuse. So again, like the balance connection side of things, which are resettable on their own, if something went wrong with the XT60 connections, which is obviously the main power wires, which is going to give the full voltage at the back, the fuse is going to go before anything else. Originally, and Steve, when he watches this, he'll be laughing away because he said to me, Ian, put those fuses on the front face so you would see them here. So if they popped, you wouldn't have to take panels apart and obviously then identify which one was wrong. You could just literally visually see or test it or pull them out one by one. But in conversation with the customer and Peter Milner, the guy who obviously I've been working with in between, because he's obviously helping these guys with the flying logistics side of things, we came to the conclusion that they were better hidden. So again, the pictures will show that I've soldered them then on the back side, so all you see from the front in around the cutouts then that I've machined into the front plastic face here is the JST, the 5-pin JST XH for balance, and the XT60 for the main power wires. So that kept it nice and neat and tidy. It did cover up pretty much all the fancy PCB we've had made up, but it looks good. And the idea with the pigeonholes as well is that it's simple. The users can then just slide the battery into place, and obviously I've created some form of framework, lattice work if you like, which again will be shown in a bit more pictures behind each one of these cubby holes. Now that was a mission in itself, how I was going to achieve that and make it work how I wanted to without paying stupid amounts of money to try and do it. And the way I have done it, in fact, has worked out quite well. I'm pleased with myself, so that's quite good. What I'm going to do potentially, because this is the first of 3, so they've been in a real rush to get this, and in fact they're still on the rush now. We really need the chargers quickly, but it's actually going to be collected tomorrow, so this is kind of a bit of a quicker video if you like. But what I might do, because I've got 2 more of these to build exactly the same, unless they say to me they want any changes, which I doubt it, I'm going to maybe make some videos of a couple of different steps as I go along of the various modules that I assembled, so it paints a little bit of a better picture about what I've done and how I've achieved it, and at the same time the amount of work that has gone into this to keep it simple yet functional, if you get what I mean. It took a hell of a lot of time for me to do this, and overall I messed up 2 boards, actually 2 of these front black panel boards here. I messed 2 up, and that was the only mistakes that I made. And the first one was really silly. The CNC router program, you can tell it, or you have to tell it which side of your CAD lines you want to machine on, and like a fool I didn't realise it was set to machine the outside of the line rather than the in, so the cutouts were then too big. Scratch 1 board, and that was pretty much the final that was actually the final program, if you like, or the final run, because obviously I'd broken it down into individual stages and everything else looked perfect apart from this. So loaded up another panel, cut it again on the right side of the line this time, without realising that the cutouts then for this custom PCBs along the bottom here, and there's 2, there's 1 across the top and 1 across the bottom, split down the middle. I didn't realise that where I'd transferred the electronic drawings and obviously my vernier measurements of a PCB in front of me to the CAD, I'd done it in reverse. So when I then flipped the main panel over to machine it from the backside face, the boards, they were wrong. I flipped the whole lot. So while everything else was okay, scratch board number 2. So that is obviously on the floor beside me, and I'll probably show you that in a minute. So anyway, otherwise, the rest of the design, I was quite pleased with myself actually. It went without a hitch. It all slipped together because I've got With this one, again, because I wanted to create load bearing faces a little bit, or spread the load a little bit, I've keyed the back of this front panel so the side plates actually fit into slots in the back of the panel, and then of course then are held in position with quite solid 58 by 58 mil right angle aluminium brackets. I think they are, off the top of my head. They're definitely aluminium, they're definitely right angle brackets. So obviously there's 4 of those to obviously give it quite a lot of strength. And then another horizontally opposed back panel parallel behind this front fascia here, whereby the power supply is mounted to. So that obviously needed to be quite strong there. And then in the server rack itself, this is the first time I've ever dealt with this in general, because while I know some bits about computers, I've never dealt with racking. But down the sides I needed some form of guide wing, if you like, or corner bracket. And obviously the supplier of the flight case then obviously sent us some. They're literally just L-shaped brackets which clip in down the side, and that then gives me the pull-out draw kind of sensation or ability, if you like, of each one of these modules. So once you remove the screws, it's not just going to drop down. You actually have to pull it towards you a couple of inches and then hold on to it, because obviously there is a reasonable amount of weight there. And I think each one of these charger modules is 5.4 kilograms off the top of my head. So not far off the weight of the deck going in the charge cases, admittedly. So it's, and that's without the charger in it. Keep forgetting about that. So it's 5.4 without the charger, but with the power supply. So it's quite heavy. So with that, then there was obviously other considerations to take into account. One of which was the mean wells, and I've got one actually beside me. I wonder if I can show you that here. Here we go. There's one of the mean wells. Basically, because we are waiting on the charge, I've just got another 4 ready to go, very dirty with the leads, and obviously protected it as best as possible, because they're obviously they need these units charging sooner rather than later. So I think they've literally had to buy 4 iCharger Duo 4010 Duos today from another company to run off the 48 volt supplies. That's potentially changing course again here a little bit. That's one of the only drawbacks with going 48 volt power supply, is that if you have a charger issue, or you can't get the chargers yet, you are very limited with the amount of chargers you can use off of 48 volts. And likewise, that's where we kind of shot ourselves in the foot. But the higher efficiency running the chargers off of 48 volts will allow us to do what we want here and stay within the realms, or should I say the specifications, if you like, or the upper limit of the PL8 Duos. So basically, from those power supplies, of course, they are going to get warm in operation. So they've got I think they've got 2 fans on the back of them, for example. So it draws air in through the front, the connection end, through the unit, and then obviously then the fans at the back, which are obviously I think they call them tractor fans, where they're pulling the air through. They'll obviously expel it out into the open air, which is fine. That's within the case. But what I've done, using one of the side panels, which is on this side actually, it's obviously mirrored at the moment, but you can see that just about there's a grill, and it'll make more sense when I go up closer to the unit to show you. But that's the hot air outlet from the side of the Meanwell power supply. So basically what I've done, I'm using one of the side panels and then the 3D printed duct, which obviously then guides the air and channels it as it comes out of the power supply towards you. So obviously out the front towards whoever is standing in front of this unit. So in theory, we're not letting any hot air fester within the case, although it's so open down the side. I mean, you can see the gaps there. I don't think it's going to get cold, but if this is inside a room or inside a tent where the air is still, that's where the extractor fans on the back of this unit obviously then just help keep air circulating and stuff without the hot air pooling in the back. So that was one issue that I managed to overcome. The other one, the right hand square here, then we have another breaker. Again, on the advice of my electronics man, he said, just to be on the safe side, why don't you put another breaker here? So that is a 40 amp breaker there as well, that sits in line between the DC outputs of the Meanwell and the input of the charger. So again, if there's any issues there, the breaker will go, or if there is something going on, the user can actually just flick the breaker and just switch off the power going to the charger very, very quickly. Don't have to worry about trying to pull plugs out, run around the back of the unit and disconnect it, because you can't get to the plugs inside it without taking like 16 bolts off. So that was another safety aspect. Going back to cooling again, you can just about see them in here. We've got one cooling slot here and one cooling slot here. Behind that again is another 3D printed guide duct, if you like. So when basically they are guiding it, wrong way, they will guide the air coming out the back, the fans mounted on the back of the PL8 Duo Touch, and direct it out again towards you coming out the front. It's not like it's going to be a Savannah heat blast on your face, admittedly, but instead of, obviously originally I was going to have another 1U channel above it with a couple of radial fans, then obviously drawing the air up and then out again towards you, or I suppose back. This was by far again the neatest and the quickest and the best solution realistically. You just need to guide the air out. So obviously again with the 3D printer, starts off with a rectangular shape, scallop it out, curve it, vein it kind of thing, so there's no sharp edges. So as the air is obviously then expelled from the charger itself, it just naturally follows a curved line and obviously then just comes out the grills at the front. Perfect. So I think perhaps I'll stop talking now. I'll switch this video off and then obviously turn it back on in a minute, and then I'll string the two together in editing. Everyone loves editing. And then I can obviously now go back here and actually show you a little bit more. I think what I can do actually, you've probably seen this here. This is one panel. This is the back panel, because obviously this is the one that's got wheels, but basically that's the back panel that clips on the back of this flight case. There's two. So there's one on the front and one on the back. This one's wheeled, so the whole idea is when it's clipped on the back, you can then just roll the case onto its back, wheel it around with the casters. There's four, one in each corner, and then when you're ready to use it, stand it upright and then unclip these side panels. And there's another one behind it as well, which is the front panel, which covers behind here. So that is another bit to show you just how big a project this one is. And as I said originally, I've got two more to build. So the good thing is that now I got the design, it is just a copy and paste affair almost, if you like. So yeah, barring any subtle changes, we got a couple more of these. And again, I think, like I said earlier, I think I will break it down and get a couple more videos, but I'm going to stop this one now because I've been chatting for 27, nearly 28 minutes, and I'm not the most photogenic, and also my hand is aching, which is why the camera is shaking a little bit more, because I've got it standing upright and I think it's going a bit dead. But anyway, I'll be back in a minute. Speak to you in a minute. Bye. Right, I'm back again. Hope I didn't bore you too much, and I hope you're still awake, but here we go. Charger module number one. So as I was trying to discuss and obviously point over my shoulder, if you like, that would be charger one. And of course then the bump controller that is mounted on the top of the PL8 Duo Touches will obviously sit here, and you can obviously see, you can just about see behind there. Obviously I've got a mounting plate there then for the charger. Again, photographs at the end of this video, and then subsequent videos as I start to replicate this for the next two builds will obviously paint a better picture. But we've got the breaker here. I have got it running, so you can see the red light is on, obviously, on the mean well, and there's the mean well. Actually, you can see that just at the back if I pan around. So that's obviously behind this unit. The mean well is running parallel behind the charger almost, if you like, with obviously a little gap between it. So hot air comes out of this slot from the mean well. There's obviously a side plate here which obviously extends back, if you like, and there's one on either side. And then obviously the back panel then is mounted on that, so it kind of like creates a box section behind this upper half of this main panel, if you like. So the side plate acts as the duct on this side, and I've got a 3D printed duct then that obviously is kind of like U-shaped, bolted here, and then obviously again it goes all the way down to the front of the mean wells, or the back end of the mean wells, and obviously then is curved slightly, so obviously then as the warmed air is fired out the mean well, it comes out and comes towards us. So that works quite well. Likewise then the two slots at the top. There it goes, it focuses, and of course then you can actually see now this textured finish. You can hear my nails scraping against it, so it's really quite a nice material actually, and it's surprisingly it machined really well, even better actually than the white or should I say the natural or white polypropylene that I buy, which appears to be quite gummy at times. This material really cut nicely, but again followed on. So we've got the bigger grill there obviously for the mean rail. We've got two smaller ones here with 3D printed ducts here. So then with the charger sat there, it's got two extractor fans that obviously pull air through it, through its obviously heat sinks, and then pull it out the back. It gets thrown up into a 3D printed duct here, and then obviously is guided out towards us again. So you've got one for each bit there. The breaker, obviously that's the DC breaker if you like, so that's the one obviously on the DC supply in to the chargers. Then if we scroll down, this is the pigeonhole effect, as I call it, or pigeonhole charging ports. So we've got the custom PCB, which is obviously a 1U panel size. So we've got one PCB here and one PCB then below. And then obviously got the XT60 and the JST for battery. I think Steve's called it A1, A2, A3, A4, and then B1, B2, B3, B4 on each of the boards. So the idea being, I haven't got one of the 4S packs, but I've got a small 3S pack. The idea is then the customer can then obviously slide the battery in place, and obviously then it kind of supports itself. You can just about see, there you go, you can see the lattice work I've created. So I've created one main spar, if you like, out of the 10mm polypropylene again, which is bolted in between the server rack rails on either side, and then I've got a load of plastic 25mm long spacers, and then obviously M5 bolts, which then obviously secure, and then obviously a laser cut piece then at the front, which has got like letterboxes cut into it. So that obviously then just stops the battery, you know, it's not going to necessarily fall into a void kind of thing. It's literally, and then obviously at the back panel then, again, so there's three space, well, there's two spaces, another space here, the main spar, one at the back, again separated by 25mm plastic spacers. The black ones there in the middle are slightly smaller, and they're tapped for M5, so M5 screw meets in the middle there, and M5 screw from the back. Another open one, and then at the back then that's kept solid, so the battery then will obviously just hit the back and not go any further. So the idea is then they'll put 8 batteries on this side, so channel 1, and it's, even though the board is one complete board top and bottom, it is split down the middle with regards to the connections, and again the photographs at the end of this will show it a bit better. I've obviously then got balance connectors then, which obviously parallel these two boards, and then parallel these two boards, and then obviously another one coming off then to each channel of the charger. And likewise then on the back of these then there's an XT90, so XT90 for this bank, XT90 for this bank, and the same for the right and the top right bank as well. And again, so I've just paralleled from here to here, from here to the charger, and then from here to here, from here to channel 1. Nice and simple. Going to work quite well. We've just got enough room there. Again, you've got about, I think, 40. You've got 40mm in one direction and 44 in the other, and that's just a few more mil bigger than what the size of the batteries are that we're having. And again, Steve, the electronics guy, came up with a good point with that actually, which you wouldn't necessarily think of. He said, and he's right, if Mr. Battery Man tries to put a battery in there and it doesn't fit, there's something wrong with the battery. It's puffing. It's then no longer the right size and shape it needs to be, so it's no longer going to fit in here. So leave that out then. Don't bother charging it. Brilliant. Nice and simple. Thought of something before we even thought about it. So that's that charger module, as you can see. And then literally if I scroll down, we've got another one. So we've got 16, actually we got 16 batteries at the top, 16 batteries in the middle, and then another 16 batteries at the bottom. So a total of 48 4S 4200 milliamp hour batteries can be charged at any one time in this charging rack. Brilliant. Don't think I've seen any more than that yet so far. And in theory, the way this has been designed, you could almost have chargers on the back of this unit as well, because they potentially only go to not even quite halfway depth. So you could almost have another bank of free chargers on the back of this unit even. We haven't gone that far yet. We're just going to basically create another 2 of these units. So underneath then the first one, we've got a 1U drawer. And obviously I've gone for a USB charge port there. I've gone for a reasonable one. There wasn't really much room to play with, so I have used some industrial double-sided tape to hold that down. I drilled a hole at the back of this pull-out drawer here, because obviously this is powered via mains with the simple like figure 8 shape shaver style plug. So I drilled a hole for the plug to go in, and obviously then that is then wired into the consumer unit in the back. So that obviously mains powered. And obviously then the idea is then I've got them a magnetic charge lead as well, so they'll put the little dongle bit inside the tablet, and then obviously this lead then will just magnetise into the connector and obviously go. So, and I must admit, the plan is for me to have one of the tablets here, so I was going to get some of the dense foam that you can get, the laserable foam, and obviously then laser cut it so it fits in here, and then the tablet then obviously lays within a cutout within said foam, so it obviously doesn't go anywhere, and then I can be clever and also do a couple of cutouts or recessed pockets kind of thing for where the lead is going to coil up kind of thing. But I haven't got the tablet yet, and I haven't got the foam to do that either. But the good thing is, again, because we're replicating it, they can have this one and get using this one as soon as the chargers arrive, and obviously I can work on that a little bit later down the line and then send that piece of foam then up to them. So that's quite simple. So we can close that. It's lockable as well, whether they will or not. You can just about see that where there's obviously the slight gap there, you can just about see, it's not very dark there, it's the black squares here, that's the 3D printed ducts for the next charger. If we go down again, obviously there's the lowest charger, if you like, and then below that then again we've got some more storage. Cool. It's quite a nice tight drawer, it'll loosen up a bit. So we've got a, oh yeah, that's a 2U, so that's a 2U drawer then at the bottom, or second from bottom if you like, and then we've got a 3U drawer at the very bottom as well, which was even deeper. Again, there was obviously talk of maybe storing the LiPos, or as many of the LiPos within these units as possible, so that again they're all, it's like a charge case I suppose. You've got your charge leads within your case, so it's all in one place. Likewise batteries here as well, but we'll see how they get on. At the end of the day they've got the ability to do it, so we'll push the drawer in. Oh yeah, there we go, it locks up. My trusty Hetty Hoover there, which obviously I'm using to clean the workshop in. It's been covered in quite a lot of plastic recently. But there you go. Obviously it's, I mean, I'm quite tall. I mean, I'm 6 foot and 6.75 feet, I think, from memory. 6, and this is probably, yeah, this is just underneath my shoulder height. So it's quite a heavy, quite a large unit. It's heavy. The flight case we calculated to be, or we were told was about 85 kilograms. Each one of the charger builds, potentially with the charger maybe, you're looking, what is it, probably about 7 kilograms each, maybe 7.5. Obviously then the pull-out drawers obviously add a reasonable amount to it as well, so I think you're probably looking at anywhere in the region of 135 to 150 kilograms here. So it's going to be a fair old weight. Obviously once you get the front and back panels clipped onto it, it then obviously creates a little, it makes it a little bit stronger. Let me see if I can squeeze through the very small gap. Oh God, like the film, we're going to need a bigger boat, going to need a bigger workshop. So at the back, not really much to see really. Obviously I cut in 2 fans there, so obviously they're AC, they're powered by AC, so I created a nice little 3D printed splitter box, which is obviously bolted on the back side of this. Again, I don't think I mentioned it before, obviously I did mention about modules, and it's all the same. So the charger modules can be disconnected via one lead and obviously removed for maintenance and sent back to me. Likewise then the back panels as well, so obviously the top one with the fans in can be disconnected and sent to me if we need to replace the fans. The next one down then obviously has the industrial 32 amp socket, and then obviously on the back of it, on the, or should I say on the inside of it, then is the consumer unit with the bolts, with obviously the breakers in it. So the power run here is very simple from inside the plug. And I think I've used 10 millimeters squared off the top of my head. Power cable from the pins into the consumer unit, and then obviously 6 millimeters for each of the, and then obviously let me squeeze by, oh yeah, there we go. And obviously then we've got various handles all over it, and they're obviously spring loaded. So we've had a few handles put on it. It's these clasps actually, it's quite amazing actually, these clasps. Obviously I'm going to have to put the panels on it in a minute. So you obviously turn it and it pushes the clamp in, and then as you turn it then the next 45 degrees, it then pulls the actual clip in as well, so it literally clamps it backwards. So if I undo it, you can see it, a bit coming out, and then halfway, and then boom, it springs out. So it's springy, it's going in, and then it's going back. Brilliant. It's quite clever little things. When you like the engineering side of things, it's quite good, and of course it's all shock mounted as well in each of the corners, so the main electronics inside aren't going to get jostled or jolted too much. They're going to have the impact taken out of it. But anyway, let me I'll tell you what, been chatting away again. Let me switch this video off here now. Thanks for watching and everything else. I hope you stay safe and well. What my plan is, I think where I'm obviously making more of these, I'll try and make some individual videos of each of the modules that I'm making, and obviously then I can describe it a bit better about what's going on and everything else. But thank you for watching. I hope you've enjoyed this one. I've certainly enjoyed it. This is a very big one. This is obviously definitely putting my name on the map with the big industrial cases, and I can't wait for the more different ones and interesting ones to come along as well. So here's to the next two. I'll be back. Stay safe. See you soon. Bye bye.